Alrighty then, we are going to do some right triangle trig today. We're going to learn about sine, cosine, and tangent ratios, also known as Sohcahtoa. And then we'll just remind ourselves of the Pythagorean theorem as well. So working all with right triangles today. First thing we're going to talk about is which sides are which, so we have some terminology to discuss. So with the right triangle, we're going to be given one angle. And the side opposite of that angle is going to be considered the opposite side. So this side, in this case, is the opposite. And the side that is across from the 90-degree angle, that is always considered the hypotenuse. It's the longest side. Because in a right triangle, you cannot have an angle bigger than 90. Sorry, you can't have another angle bigger than 90. Early in the morning. So that's the longest side. The opposite side is the one that is, again, straight across from the angle that you're given. And then the other angle that is next to the angle you're given, that's touching the angle, it makes up one of the sides, is the adjacent. So these three terms are really important. If you don't understand these, you're never ever going to get any of this stuff. So a hypotenuse, opposite of the 90, opposite side is opposite of the angle you're given, and then adjacent is next to the angle or touching the angle you're given. Okay. So we're going to talk about this ratio called the sine ratio. Okay. So the sine is relating to the SO in Sohcahtoa. And what that means is the sine ratio is always the opposite side divided by the hypotenuse in any right triangle. So in this case, you'll see here we're given an angle, 30 degrees. Okay. The opposite side of that angle is 6. Right, so there we have our opposite side. And the hypotenuse of this triangle is 12. And so what the sine of 30 degrees, in this case, that's the angle we're given. So say we have the sine, that's how this is pronounced, by the way. Some people say sin, but it's abbreviated just with sin. So the sine of 30 degrees is the ratio in this particular triangle 6 divided by 12. And it always is the same in every right triangle that has a 30-degree angle. In fact, we just got done talking about this with special triangles with the 30, 60, 90, because this is a special triangle, 30, 60, 90. Okay, so the sine of 30 degrees is equal to 1/2. And you can see that I have this old school table of values. When I was doing this in middle school, and I learned this stuff back in like 9th grade, we use these tables like this. So you can see here's all the sine values, and here's all the angles going from 0 degrees all the way up to the biggest angle you can have, which would be 89. And then at 90, you notice the sine is 1. So those are all the angles. In this case, we are working with the sine of 30 degrees. And if you look in the table, there it is. It's 0.5. It's always 0.5 for any triangle, no matter how big or how small. Okay. And another thing that we learned in geometry, not to get too far off task here, but we learned that triangles that have the same angle measures are similar. So like any other triangle, 30, 60, 90 that you'd make, let's just make one up here. Let's say this, if you got 30, 60, 90, right? Let's say the opposite side is 2. Okay, well, what does the hypotenuse need to be for this one? It needs to be 4. It for sure is 4 because the ratio of the opposite side divided by the hypotenuse in every single 30, 60, 90 triangle is going to be equal to 0.5. There it is. It's for sure. It's guaranteed. They're the same shape triangles, just different sizes. They're similar triangles. So that's how we know all these values for sure are what they are. Let's take another one down here. Let's say we have down here, we have the sine of 15 degrees. And I know to use sine because I looked at my opposite side, because here's my angle, 15. So opposite of 15 is 1.29. And the hypotenuse, I'm just going to use O and H now. The hypotenuse is opposite of the 90-degree angle. So I have my opposite and hypotenuse. So the sine of 15 degrees is equal to 1.29 divided by 15. Okay, and 1.29 divided by 15, if I pull up a calculator, or I just ask the watch or whatever, 1.29 divided by 15, was it 15 or 5? It was 5. Is equal to 0.258. And if I go and I look in my table, the sine of 15 degrees is 0.258. There it is. It's the ratio of the opposite side divided by the hypotenuse in any triangle. Okay, and that becomes handy because now you'll see after I'm done talking about this, we'll be able to use that to solve for missing sides. So cosine is very similar, but using different sides now. Cosine is going to use the adjacent side, and the h is the hypotenuse. So here we have an angle 30 degrees. Okay, in this case, if I say the cosine, which is abbreviated by COS, cos, we say cosine of 30 degrees is equal to, now cosine is equal to the adjacent divided by the hypotenuse. It's a ratio of the adjacent over the hypotenuse. So in this particular case, it's going to be 10.39 divided by 12. I just set these problems up for us to work on and then just recognize the ratios. So what is 10.39 divided by 12? Well, let's check it out. 10.39 divided by 12, 0.865. All right, let's look it up in the table of cosine values. Here's the cosine values. There it is, 0.866. So, I mean, that's how you determine what cosine values are. They're just the ratio of the adjacent divided by the hypotenuse. Same thing down here. If we go cosine of 15 degrees, that's going to be equal to, in this particular triangle, again, it's the same shape as these. These two triangles are similar. They're the same shape, just different sizes. And so if I take the adjacent side, which is 9.66, and divide it by 10, I'm going to get the cosine of 15 degrees. Cosine of 15 degrees is 0.9659. So they're very, I mean, 15 degrees is a small angle, so the adjacent side is going to be very close to the same length as the hypotenuse, but not longer because the hypotenuse is the longest. So let's talk about the last one, the TOA, the tangent. So this is TOA, so T goes with O and A and makes TOA, and that's because the tangent is equal to the opposite over the adjacent. And so in this particular case, I have my opposite side, I have my adjacent side. Hold on, I have to take a baby timeout, and I can't pause this. Here, buddy, you'll be all right. Do you want to hold him for a little bit? Hurry up, because I'm live here. All right, Nova to the rescue. Okay, so tangent is opposite over adjacent. And in this case, the opposite side of my 30-degree angle is 6. So that's my opposite side. My adjacent side right next to the angle is 10.39. So the tangent, we say tan, of 30 degrees is equal to, I mean, I can just look it up right now. Tangent of 30 degrees, I know right there it's equal to, in the table of values. By the way, these are all stored in the calculator now, but the table of values is 0.5773. So 6 divided by 10.39 would be 0.5773. So that's a little bit about tangent. Tangent is the opposite over the adjacent. And those are the three main trigonometric ratios. We call them Sohcahtoa. That's just Sohcahtoa is just to remember which side goes with which. I'm going to skip that one for now because we're running short on time, but I'm going to show you how to use these. So here we go. There's our Sohcahtoa up there, and this is just a mnemonic device to help us remember which one goes with which. So like S is the sine, and that goes with opposite, right? Opposite. Oops, I need a skinnier font there. Opposite over hypotenuse, right? Cosine is adjacent over hypotenuse. Toa is opposite over adjacent. So is the sine, starts with S. Cosine is the Ka, it has a C. Tangent is the Toa. It's the one that has a T. So here's how we use it. We're given a triangle, and we are missing a side. Okay? So the side we're missing in this case is the hypotenuse. And the other side that we're given is if I go to find my angle, I go straight across, I recognize that this is the opposite. Okay, so the two values that I know are my hypotenuse and my opposite. Now what that tells me is which ratio to use. I'm going to get rid of that stuff. So which one of these ratios has O and H? That would be the sine ratio, the SO. See, I can highlight all the ones. This one has A and H, cosine. Tangent has O and A. So whichever two sides that you are given, that indicates which ratio to use. So now I'm going to set up a problem. The sine of 26 degrees is equal to the opposite over hypotenuse, right? Because remember, sine equals the opposite side divided by the hypotenuse side. Okay? And so the sine of the angle, 26 degrees, is equal to the opposite side, which is 5, divided by the hypotenuse, which is my unknown value, x. Okay, now if you remember from earlier, the sine of 26, that's just a value. I can look that up. If I scroll way up to where I started here, the sine, here's all the sine values. So I needed the sine of, what did I need the sine of? 26 degrees. So 26 degrees, I know in my table of values is 0.4384. So 0.4384 is really the value of this, 0.4384. That's the value of the sine of 26 degrees. So it's just a number. So all I'm doing is solving a proportion here. But with our technology now, and our calculators are pretty slick, we don't really have to look things up in a table. We can just write them out and type them in a calculator pretty intuitively, and it'll give us the values. So I'll show you what I mean. I'm going to use the cross products here to solve this proportion. So I'm going to take x times the sine of 26 degrees equals, and I use my other cross products, 1 times 5, which is 5. Now remember, the sine of 26 degrees, you just treat that like a number. It's 0.4384. That's the number. But in the calculator, you can just type it in, the sine of 26 degrees, and it will essentially treat that like a number, 0.4384 as well. So the next step to get x by itself is to divide both sides by the sine of 26 degrees, which really you're just dividing by 0.4384. Okay, then what's happening here is the sine of 26 degrees, those cancel out, and I'm left with my x all alone, and so x equals 5 divided by the sine of 26 degrees. Okay, now it comes time to calculate that, so I'm going to go into my calculator, and I'm going to go 5 divided by, and then I got to find my trig functions, which I think would be in this button, functions, and the first one is trig, so then I go sine of 26 degrees. There you go. 6.556 or 6.6. X is 6.6. And we can't use, that's the only way to solve that. We can't use any other method because we don't have enough information. We only have one angle and then one side in the right triangle. Here's another example. What sides do I have here now on this one? I have my hypotenuse again. Zoom in a little more. I have the hypotenuse, and in this case I have the angle right next to the side right next to the angle, so that is the A, that's the adjacent. So I have the hypotenuse and I have the adjacent. So which one uses the A and the H? Which ratio? That is the cosine, the C, the one with the C. Okay, so I'm going to go to my cosine ratio. I'm going to use the cosine of 64 degrees, and that equals the adjacent side, x, over the hypotenuse, which is 42. Okay, now I have that set up. I'm going to use my cross products again. This is always over 1, so I just write it over 1 so we don't get confused. We have x times 1 in this case, so the variable's in the top, so this is a little easier. So I get x times 1, which is x. And the other cross products are 42 times 64. And so I'm going to write that out like this, 42 times not 64, the cosine of 64. So I have a baby crying in my background here. Okay, so 42 times whatever the cosine of 64 is. Remember, we could just look that up. We have cosine of 64. It could be in this trusty little table here. It's going to be 0.4384. Okay, so I could just replace that with 0.4384 and be done. 0.4384. If I just had a very simple calculator only, I could look it up in the table of values. Take 42 times 0.4384. 42 times 0.4384.
That would be
18.4128. So 18.4. Okay. A fancier way to do that, 42 cosine 64. Type it into a nice newer calculator. 42 times the cosine of 64. And we get 16.45. So how did I get that off? 42 cosine 64. Oh, wait a minute. No, wait, the discrepancy here. 0.434, 42. Cosine of 64 degrees. Did I look it in the right? Oh, I looked it in the tangent? No. 0.4384. Okay. I gotta check something in decimals. There is something that you have to be sure. And I'm not very familiar with decimals, but yes. This is not in degree mode, it's in radians. Shoot. So it has to be in degree mode. So see how those answers switched? I clicked to radians. Went from 16 to 18. And the last answer was wrong too. So the last answer was 6.55, and it should have been 11.4. So 11.4 was the last one. Well, I better fix that too. Yeah, it didn't seem right, did it? Okay, so this one should be 11.4, though. I had it in radian mode. So make sure the calculator, I can't believe I forgot about this, is in degree mode. Has to be in degree mode, otherwise it doesn't give you the right answer. Yeah, another reason the trusty table might be a little better. So 18.4 is not correct. It is 18.4, right? Yeah, 18.41. There we go. All right, last one here. This one is going to have, let's see here, the opposite is 12. And this one also has the adjacent is missing. That's the A. So the A and the O, which one uses the A and the O, or the O and the A? That is TOA. The T one, the tangent, uses opposite over adjacent. So in this case, the tangent of 18 degrees, the angle they give us, is equal to the opposite over the adjacent side, which is 12 over x. Okay, so my variable is in the denominator again. Alrighty, well, that's fine. I'm going to use my cross products. I'm going to do x times tangent of 18 degrees is equal to 12 times 1. Okay, when the variable's in the denominator, if you've done enough of these, you'll realize that when you solve them, you're going to have to divide by the tangent or cosine ratio, whatever you're using. So in this case, I take 12 and I divide it by the tangent of 18 degrees. Again, we could look it up in the table, the trusty table, tangent of 18 degrees. That's going to be 0.3249. So really all we're doing is we're taking 12 divided by what did I say? 0.3249. So I could say on my watch, 12 divided by 0.3249.
It's about 36.9344.
36.9344, or 36.9. And I could verify that on the calculator by doing 12 divided by the tangent of 18. Some functions, I do tangent 18 degrees, 36.9. So there we go. That is how you find missing sides using the sine, cosine, and tangent